to our session.
Welcome to our session this morning. We're going to be talking about security. This is the first of two sessions which we'll be covering. What I hope to do is that I'm going to assume that many of you are not very familiar with the subject, so we're going to go through an introduction of what we're going to cover. So with that being said, I'll just go straight to the other part of the agenda. So this is going to be our agenda, part one. So we're going to talk about the well-architected framework before, which will then talk about the security pillar. We'll look at the AWS shared responsibility. We'll look at security best practices in the cloud, and we'll then subsequently look at the network security as a whole, as being part one of this agenda. In part two, we'll cover some other areas, but we'll see what that would be from tomorrow. No, from next week. So security in the AWS cloud. Okay, so before we start this topic, the first thing I'd like to do is to start with the definition of security. I mean, what is security? And of course, we can look at a dictionary definition, but in all, when we look at all these things, there are a number of things that come up when we look at security. And you can see here that all these areas here, whether it's to do with physical security, whether it's to do with security from a point of view of being, having assurance for your own safety, or it could even come down to having more or less, when you have, let's say, some certain financial tools, all come in the aspect of security. But that being said, I think primarily what we're going to look at security here, it's all about feeling safe. That is the primary reason. So you have freedom from risk or danger, or having freedom from doubt or anxiety, or having confidence that you're feeling safe, or giving the assurance that your own physical safety, or anything which is connected to you being safe, or let's say your financial safety, or from a health point of view, you know, all comes down to, to you being safe, uh, or for you being healthy in a particular shape or form, or it could even mean financial security. So that's why I just said we just start off with a definition around this. So all these things can just come into play. But then again, you start, at least when we have that textbook definition, we can just see what it is. So we can see here that when we look at security, it all depends on the context. Yeah. So it looks at taking precautions, to make sure that your particular assets, which you have, are protected from anything. It could be from theft. It could be from spying, from sabotage. And when we even talk about security as well, it's all talking about the means by which you would take to actually defend or to protect those items which are most important with you. So I'm looking at this from a very general point of view. So it can do with anything. So when we're going to apply into information technology, and specifically to the cloud, you would see these main topics coming up under security. So there's all about defending, all about protecting what you have, and taking measures that will stop people from actually compromising your information, actually taking that information away. So in the process, what you're getting is you're getting confidence that your system is safe. You're getting peace of mind. You're getting safe. You're feeling in a state of being safe. So when you'll see certain topics being or certain items talking about, let's say there's a shield in place, there's a guard in place, there's a certain level of assurance, there's a certain level of inspection. These are all terms which are all associated with security. So when you start seeing these terms being used um, around um, protection, guard, safety, confidence, uh, assurance, inspection, compliance, you know that you're talking about, you're in the realms of security. So I think when we've looked at security, it's all about what we're associated with. So I think the best thing to do is that if at all you want to talk about security, you have to ask yourself, well, if at all we have to look at security that is protecting oneself or being safe, then there must be dangers out there. And then this is one of the 10 most common cybersecurity threats, which courtesy of Cybersecurity Kings, which lists the various security threats that are out there. Now, I'm not going to go into the actual definition of each and every one of this. I mean, the link is going to be there, so this will give you some future reading. I mean, this is not something that comes up straight within the program itself, but at least it gives you the context of starting to appreciate that there are dangers in the IT world, just as there are dangers in the physical world, where you can see that there are threats out there. So these are the threats that you'll see that are most common in the cybersecurity world. So now that we know that there are threats out there, then how do we go about responding to these threats? Now, AWS has a way of doing this, and this is called the well-architected framework. Within the well-architected framework, this gives you a means by which you can assess the suitability of your cloud computing environment. So this is based on best practices in terms of architectural design and making sure that your actual resources and your actual systems in the cloud are working in the best possible way. Now, one of those areas which make up this well-architected framework is security. So we can start to understand now how important this is in terms of what this delivers for cloud services. And so any kind of thing that we do, we always have to have security in mind. So that puts it in context. So within the security pillar, what exactly does this mean? So the AWS security pillar, we are of course looking at an area of architecture, an area of cloud delivery services, which the responsibility for delivering this is not uniquely solely on the cloud service provider. So in this case, we are referring to either AWS or it could be, any of the other cloud service providers such as Azure or GCP. The responsibility for delivering security is a shared responsibility. That means that you as the client or you as the person who is uh, getting the services from AWS or wants to use cloud services has a responsibility to security as well as the cloud service provider. So the best way to look at this is that there are two terms which are being used. So the security of the cloud, which is what the cloud service provider delivers, and then the security in the cloud, so that whilst you are using a cloud, you are using a platform which is there, you are responsible for the content which is inside there, for securing that content. So I think the best analogy to look at it is that if you have a home or if you have a house, um, AWS will provide the security, let's say the four walls and the roof in terms of the security. And then what's inside, the content that is inside that house, becomes your responsibility to secure that as best as possible. You have to make sure that your windows and your doors are locked, and you have to make sure that you can put an alarm if at all somebody breaks in. So those kind of safety precautions which take place, which are inside the house, will become your responsibility. So that's an analogy of how we see things. Yeah. So with that, let's look at what the shared responsibility model actually looks like. So some of you may have seen this diagram, but basically what it does is that it shows a division of labor. So a division of uh, o- o- of roles or tasks which are attributed to you, who is the client, who is using cloud services and the cloud service provider, which is in terms of AWS. So let me start first with AWS. So what you can see there are a number of entities which are very important in order to secure. So the most important thing is that the physical security of the cloud. So as you know, cloud services are delivered from a data center. That data center is owned by AWS. So AWS has the responsibility of providing security to that data center. So physical security. So making sure that that data center is safe um, from attack, safe from unauthorized personnel entering in and out. And not only that, so that falls under what is called the global infrastructure and covers places like the regions, the availability zones, and the edge locations. It involves elements such as what is called disaster recovery. So making sure that if at all the data center is compromised, one data center is compromised, there are other data centers that can come in. So you're getting to start to see the picture that security in itself doesn't necessarily mean your own physical security, but it also means having contingency plans. So we go a step further in saying that what does also that security entail? It does entail providing, delivering the provisions which you need for a cloud service. Those falls under compute software, databases, and networking. And on top of that too, the actual software upon which your cloud services will be running under. That is what the base which the cloud service provider. So all these bits in orange are covered in. Now, beyond that, right now, everything which sits upon that is then the responsibility of the customer. So as we'll get to see right now, we'll see how we as the clients, as the customers of AWS, of the cloud service provider, can make use of the security terms. Okay. So as I just mentioned here, which I'll go very quickly, I've covered physical security. You'll read this in your own time. There's the infrastructure layer, which I mentioned. So these are just notes for you to just take into account. And there's data layer security. So these are the elements which AWS provides, which have elaborated in a lot more detail. So they're just useful for you to just understand what it is that AWS provides. So once you understand that, then we fully understand what it is that AWS is responsible for, so that in the end, any other thing that we have to do, we know that we have to address our own security element. Okay. So with that being said, we're now at the next phase of this where we're saying, okay, what are the security best practices in the AWS cloud? There are many security practices that can be adopted for any cloud provider, but we're looking specifically at AWS. But what you would find is that depending on whatever cloud that you're using, there's some element of commonality that exists within this. Okay, so there are seven principles to securing workloads and to securing resources in the AWS cloud, and they're listed as such there. So we'll look at every one of these in turn. So principles of least privilege, which you'll encounter. So what you would find about these things is that as you start doing topics within the cloud practitioner, you would notice that there'll be an element within each topic which addresses security. So whether you're dealing, let's say, with storage, there'll be an element about storage security. There'll be an element about databases, you'll be dealing with security. You'll be dealing with networking, there'll be an element of security. You'll be dealing with compute services, there'll be an element of security of how you can secure your compute devices. At the same time too, when you start talking about, oh, how do you monitor or how do you audit or how do you trace any security breaches, that also falls under security. So you start to see now why security is so important, and it gives you, this shows you how exactly you can take steps, active steps to protect your environment as you go along. So let's start with the first option, which is the applying principles of least privilege. Now, This falls under what is known as the identity and access management area. So we all understand what identity is. So actually, we start to understand um, when you want to access a system, it's very important to establish the rules by which you can access that system. Who is authorized? Uh, First of all, providing authentication, finding out who you are. Um, that is very important. Who you are is important. The authorization in understanding whether you are allowed to see access to access that system. Mm, and then having the accounting element there, which is which is more or less related to whether you can track who has access to what and when and the time. So, but what you find is that what you can do is that you can apply this principle of least privilege, which means that you only allow people access to a system um, for on a need to know basis, right? So if you have a system which gives access to which has 10 items, for example, if at all people in this group only need access to 2 items, then we'll limit that access to just those 2 items out of 10. So we don't provide access to all the 10. So it's only limited to the applications or to the resources which the people in question actually need, for an example. And here, what I have done is that I have listed a number of resources or AWS cloud native services which are used in order to apply this principle of least privilege. So we've got elements which relate to all identity management. So there's AWS Identity and Access Management, AWS Single Sign-On, AWS Resource Manager, Amazon Cognito, and there's AWS organizations. So basically, these are elements by which you can control access and deliver least privilege there. So you'll cover this in more detail under identity and access management. So some of you may be familiar with some of these services already. We'll look at them in greater detail in part 2, but this is just an overview. So moving on to the second element, enabling traceability and monitoring. So in order to be in a very secure environment, you must be able to actually verify to check that you are safe. If at all you suspect that you have a breach, what tools do you have in order to make sure that your environment is safe or you're being able to track what it is that has been compromised? Now, there are two main tools that actually help you do that. Amazon Guard Duty and and AWS Cloudtrail. Right. So what is AWS Cloudtrail? Now, Cloudtrail is actually a service which is very important. It's a service which is delivered to you free of charge because it gives you an audit. It gives you more or less a recording of what has been happening on your cloud environment. So it records every single change, every single thing that you do, when it is done, who did it, for how long, so it actually tracks all of those things and is able to give you that element available free of charge for a period of 90 days where you can check this element. So as you say there, it's very good for auditing purposes. So it gives you a 90-day record. And on top of that, if you want, you can then store that element in an archive, which you can then refer to at a later date. But very important for industries whereby elements of compliance and good governance are required. So AWS CloudTrail is a very, very important uh, 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 service. And guess what? It's available free of charge. So when I talk about free of charge, that's going to be very important because we don't want to be spending money unnecessarily on tools. So knowing that you have a free service is a very good point. Then we have other elements such as guard duty, which uh, provide a good element of providing you uh, um, with a level of protection. So actually checking your services. So I'll follow up with guard duty in much more detail at a later point. But these elements around traceability, monitoring, and auditing um, are the two main areas that you should know. So you've got guard duty and Cloudtrail. So we'll move on to the next element, the third element. So we look at providing security across all layers. Now, there's a way that we can do this. When I talk about all layers, what do I mean? So there are many layers of security within the element. So in the cloud, uh, we will start first with understanding what it is. So there's compute. There's a compute layer which is there. There's a networking layer which is there, which is in place. There is the operating system layer, um, which is also in place. So at least there are those three different layers. Or alternatively, you can look at it this way. Whenever you set up any system in the cloud, there's a three base architectural model, right? So you have the web front end, um, you have the database, sorry, you have the application layer, and then you have the database layer. Yeah. So WAD, so those three base layers. So when you're looking to provide security, you want to provide security across those three main layers, the web front end, the application, and the database. Mm. So that segments your network segments your cloud environment very in a very simple way, and you know that okay, you can secure each and every one of these elements. So there are three main devices or three main services there. There's Cloud HSM. Now, this is not strictly a cloud service, but this is more or less a tool which helps you to protect your elements, provides you with encryption. Encryption is all about masking or providing an element whereby you can uh, um, uh, encrypt is to more or less safeguard the data uh, by making it unintelligible to people who do not require access to it. There's single sign-on as we've mentioned, and then there's secrets manager, which is another tool. So this is just identifying the key tools there. We'll cover these in a little bit more detail in part two. Okay. Yeah. So the next one is all about automating security operations. What you'd find is that security in itself is quite complex, and when you're dealing with security in the cloud or with IT systems, is that you find that you're looking at many systems at a time. So you are making assessments as to what is really happening. You are inspecting a lot of data points. You're looking at a lot of endpoints. You are looking at a lot of data. The fact of the matter is that you can be overwhelmed by all the information that is coming through, and you're going to you will need to apply, you need some help, and applying that help comes in the form of using what you call automation. So automation is more or less providing a tool that helps to assist you in analyzing all this security information that is coming through. And there are two main elements that do that. There's Amazon Inspector and there's AWS Config. So Inspector is all to do with identity protection, um, and AWS Config covers another element of that, which we'll also look at. So the automation, I think the main thing there is to use tools, and those tools will come under the element known as infrastructure as code. So you can more or less set up a program which would actually carry out a level of a task, a security related task for you. And this helps to eliminate human error in a lot of times. So you can concentrate on other tasks. Meanwhile, you have all these automated tools doing the work that is necessary. Okay, right. So that being said, we understand at least why providing automatic operations in security greatly assist us. So going to the next one. So in addition to that task as well, the other main thing that we have to do is one which is central to everything to do with security. It's all about protection. Um, what we have to ask ourselves whenever we're looking at a system in the cloud, how do we protect ourselves? What is important for us to protect? Is it important for us to protect that database? Um, we have the data out there. How important is that data to us? If that data is important to us, how do we protect it? Yes. So we then have to look at the means by which we protect it. If at all we have all our resources being put um, a, into a cloud entity, which in most cases the cloud entity that we have is a data center in the cloud, which is actually a virtual private cloud, a VPC. How do we protect that VPC? It is connected to the internet. How do we make sure that nobody from the internet can come in and compromise our resources, which is on the AWS cloud? So this is where we're looking at protecting data, mm, data which is either moving, which we term in transit, or data which is static. So data which is being stored, which is under storage. So it can be stored in a definite repository, or it can be stored within an application. So this is data at rest. So there are a number of tool sets that we can use to do that. So it will involve elements to do with authentication, providing secure network access, using VPN technology, virtual private networks, um, and what is known as TLS or SSL, so secure socket layer or terminal link services, and all elements regarding encryption, so more or less encrypting those data. So there are four different elements that stand out here. Key management services, which forms a form of encryption. So when you talk about encryption, you're talking about using a key or using a device or a mathematical device, a program that helps you uh, uh, to keep data secret, and also to make sure that to decrypt it, so that to make sure that that data is is not secret. There's a certificate manager, which is a scheme which is also used to provide security assurance, especially for data which is in transit. Amazon Macy and Amazon on AWS Cloud HSM also look at other encryption standards, which are very important for us. Okay, so this element is going to be extremely important when we look at the cloud. So above and beyond anything else, it is just very important for us to secure our data, and these are the steps that we'll take to do it. Again, we'll go into these a little bit more depth when we go. So this is the highlight of what we have. And finally, this is all about now understanding, okay, how do we then deal with matters related to a security breach? Are we always going to be aware what happens when a security breach uh, uh, um, um, happens? What can you do if a certain security instances happen? What do you do? Let's say if your compute resource is compromised, what are the steps that you can take in order to provide you that level of security? So we have here AWS Artifact. In fact, there's also another service which you can also use as well that can alert you to security incidents. That's called under CloudWatch, which I didn't include there. So my apologies for not including that. That's supposed to be listed there, as well as AWS Artifact. So when I'll send the updated slides anyway, I'll put the AWS CloudWatch. But the main thing to look at there is that when you ask yourself that question, is that how do you build a secure cloud, and how do you make sure that your instances and the incidents which you have there um, make more or less protect you. Um, there are other elements which also come into it, where we're talking about AWS Shield, uh, uh, AWS Shield, which provides elements from protection from what is known as uh, directed denial of service attacks, which is also inclusive. So that will also come into play, which we'll look at on in the next section. So with that being said, we come now to the last area, which I've talked about a little bit, but this is all about minimizing the attack uh, the attack's surface. So it's not really the attack service. It's surface, SURVFACE. So my mistake there. So minimizing the attack surface is all about safeguarding your resources and being ready to scale or really take steps to absorb the attack. There are two main elements which I talked about there, which are similar uh, uh, to what I just talked about. So there's AWS Shield and AWS Web Access Firewall. So a firewall is more or less provides you with security. So it's just like a fence or a gate that stands in front of your house, which provides you a level of physical security. So that's the analogy that you use when you talk about a web application firewall. Um, and that provides you security not across all layers of what is known as the uh, open open systems interconnect, which is a framework which is used for you to describe IT systems. You then have AWS Shield, which is another element which you can provide you a level of protection on the OSI layer as well. So when you are dealing with the networking element, we'll cover what is known as the OSI layer, which is a framework for more or less segmenting all the roles and responsibilities that you will encounter within a an IT system and effectively when you're dealing with the cloud, look at the cloud as a big IT system. The main difference is that um, who controls that IT system? You have a cloud service provider that provides the IT system upon which you depend on which you're relying for service. So minimizing the attack surface right now relies on these two elements, which one focuses on the networking layer and the other one now focuses on higher layers, what is normally known as layer 7 protection. So you can see that there's layer 3, layer 4 protection, and then got layer 3 protection in terms of shield, and then you got layer 4 to layer 7 protection in terms of the WAF. So more on that later. So that concludes the seven elements as we mentioned, which are there. So uh, when you think about the cloud, just always note that you're talking about this in terms of providing security across those seven different areas. So rather than study or learn about, let's say, about all these services in the cloud and what they do, just understand that those seven principles which we covered helps you to understand where those things can be applied. So you can start making some associations. So with that being said, right now, we'll look at network security. Um, and this is an important element around it because cloud computing is basically is all about providing a data center. You're providing a data center, which is a place where you put all your IT resources so that you can use. The difference is that that data center is not controlled by yourself. That data center is actually controlled by a third party, which is the cloud service provider. More specifically, that cloud service provider is AWS. So the first part of it will be network security. So what are we going to cover in this section? So this is what we'll cover within it. Uh, I'll just pause very briefly for a sec for please sorry. I'll just before I start this, um, I may just take a brief pause and say, uh, is there anyone? Any questions that you have, just please note them. There'll be some time at the end of the session for us to cover this. So in this section, I will cover these three topics. I'll cover what is known as a VPC, understand what it is, what is the fundamental networking element when we look at the cloud. I will then cover two main instruments by which we deliver security in the network component of the cloud. And then I'll look at another instrument that can help us to actually monitor events within our cloud network, which is called the VPC Flow Logs. Okay, right. So the first thing about the VPC, so before we start talking about the security of the element, we need to understand what a VPC is. So a VPC really, when you think about it, and as I mentioned, it's really your own data center in the cloud. So a data center is a place which you can put security resources where you have your servers, uh, you have your applications, you have your databases, you have your storage, and you have your networking all in one place, right? When you're dealing with AWS, AWS gives you a building block. That building block is your VPC, which is the fundamental element from which you have your own data center within the AWS network. So this is a shared service, um, which is, you take, but you are given a certain portion of that service to use. And there are two types of VPCs, as you'll find out. So when you start doing the networking element of this, you'll hear of what is called a default VPC and custom VPCs. So a default VPC is the VPC that is available to you from when you request a VPC from AWS, they'll give you a VPC. So that means that um, it comes with a standard tool set. So that will include things like IP addressing. And IP addressing is a very important way of actually identifying all the components that are going to reside or are going to be within that virtual private cloud. And then there's custom VPCs. So a custom VPC is all about a VPC that you set up yourself and then you tailor it or you set it up how you want it. Yeah, yeah. So the long and short of it is that a VPC is really an AWS resource which you use to deploy all the services which you want to run in the cloud. Okay. So that's why a VPC is so fundamentally important to all that we do. And it's the core itself. So that is the core networking element that we have. So what are the building blocks of a VPC? In order to understand how to secure a VPC, we have to understand the components around it. And with that, we have these elements which are known as subnets. Um, Subnets, when we talk about subnets, it's all to do with what is called addressing. Um, Addressing is just a means of identification. So this is the mechanism by which we can identify all our components which sits within our VPC. And one way of really doing that is using what is called subnets. So subnets are more or less called are partitions. So if you think that you have a house, when you think about a subnet, a subnet can be a room, one of the rooms inside your house. So you see your rooms are partitioned. So your house in itself has rooms which partition sections of your house into different components. And within each room, you put different types of things inside. So that's the same thing which a subnet does. So it partitions your network. Mm. So your VPC is your house, and then your subnets are your rooms which are inside that house. And then similarly as well, what you can also notice that within those partitions, there are some which are available, which are accessible to the public. Let's say any random person can come inside. Um, and there are some elements which are not accessible to the public. They're private. So for example, let's say your bedroom is a private space where only you go inside. Yeah, you don't allow anybody there. What does that mean? You put things under lock and key. If it's a public area, let's say it's a sitting room, then you can allow anybody or your living room to come in there. Those are the kind of associations that you have to look at it. Um, the best way to look how to do that. Then you have what is called route tables. So route tables are more or less like directions. So these are the signs that show where you have to go. It more or less identifies how to get to a particular room or how to get to a particular partition. So it's either public or private. You use what are called routing tables. So these are the building blocks of a virtual private cloud. Yeah. So how does this actually look like? Um, and this is important. What does this look like? So as you can see here, we have the AWS cloud itself. It's a very big house, which is shared by many people. Many people live inside that house, and inside of that house, let's say there are many flats or many apartments, right? And then we are given one apartment, which is a VPC, and inside that VPC, of course, we partition it. We've got an area which is private, which is entirely up where where nobody has access to, and we've got an area which is partitioned, which is public, which we allow people to come into those areas. So you can get to see now what this actually entails. Now, in terms of a VPC itself, a VPC a VPC actually spans what is known as an availability zone. So when you actually deal with the topic of what exactly we're talking about in cloud computing, we have the concept of an availability zone. The availability zone is really just a data center um, in itself. So it's a physical area which AWS owns and manages, right? And within that data center, that is where we are given uh, a virtualized room, you know, a portion of that. And there are multiple availability zones across different parts of the world. So, for example, I'm based in the United Kingdom. Now, in the United Kingdom, that is a region in itself. Now, within that region, you have multiple availability zones. So that means we have at least 3 data centers within the United Kingdom area. So these 3 data centers are used by customers. Um, and within these data centers, these availability zones, we have a VPC. And a VPC itself, you can have that VPC being present in those availability zones, in those other 3 data centers. So that gives you an example, right? So once we understand how things are being built, then we can start to understand how we can protect it. So this gives you an introduction into we how we can start protecting our assets within the cloud. And in order to do that, we have to understand how the cloud is built. Okay. So that being said, I'll go to the next part. So I think the reason why we're spending time doing this is because it helps give us an understanding of when we start talking about protecting services, you start to understand why you're protecting services and why those things are useful in delivering you services. So once you have the picture in mind of what it is, then you can start to see, like I mentioned, I said the association, the best thing to look at it is that, okay, how do you protect your own house? How do you protect your own home? What kind of things? Then you can start to make mental associations with what actually happens in the IT space in what you're doing. So we have network controls. These are tools um, which help to control who has access to our VPC, right? So we will use um, we would help to isolate our applications, or we'll use some certain kind of technologies which would allow us to access those information, access that environment over securely over the public space. Okay. Now, this is where it gets very, very interesting. Okay. So when we're talking about a VPC itself, we have to understand that everything happens in layers, as I was mentioning, and there are many ways to look at layers within an IT environment space. Yeah. So in the point of view of a VPC, as I mentioned, so the VPC, as I mentioned, is more or less like an apartment, which is within a big house. Mm. So within that apartment itself, you can think about that within that apartment, you have that your box, that your box that you put under a box or container, which you put under your bed. Now, I'm not saying you should put anything valuable under your bed because that may be the first place that some bad person goes and looks at. You put your money under your mattress, that kind of place. That's the analogy. But I'm just saying, just bear with me here. So the most important element there within it is, let's say, your compute instance. So this is the actual bit of hardware security of hardware upon which your data, your applications, and your services will reside. Right. So that is the you can the analogy to use is that that is your treasure, which you need to protect. Yes. Now, what is the first layer or what is the first means by which you can protect that? So when you're talking about compute, which is all to do with the EC2, Elastic Compute Compute Service uh, element there, the best way in order to protect your instances is using security groups. And we'll cover this in a bit later on down the line. And beyond security groups, what else can you do? You can use what are called network access control lists, mm, which are called NACLs. And beyond that other layer, there's a third layer, which is called the subnet routing. So this is actually talking about the how you get in and out of of the VPC itself. And those will require some other physical devices known as, that I mentioned earlier, such as the firewalls, such as the DDoS protections that I mentioned. So this just shows the level of layering that is used to protect. So you can see that somebody that has to actually access this has to go through 3 different walls in order to get to what you need to do it. Uh, but I think the most important thing to mention here is that you need to set these walls up, right? Don't just believe that because you put this thing within, you've put something within your bed, within a room, in your room, that it is safe. You have to make sure you put locks on your doors. Um, you have to, that's essentially it. Make sure you put locks on your doors. Make sure you shut your windows, shut your doors. Also make sure that you have certain things that can alert you to it. And it's not only actually locking your doors as well. It may be that, okay, you want to keep your place safe from, let's say, from fires or from damage, um, or from anything that can interrupt or can disturb. Because another thing is also important. If somebody prevents you from accessing your information, then they've compromised your safety. It's not only somebody coming in and taking something which is valuable to you. Somebody can stop you from accessing that information when you want it. Uh, that is compromising your safety. Somebody can come in and damage this and make sure that you can't get access to it. That is compromising your safety. So you get to see how safety is such an important component of our IT systems. So let's move on. So that being said, how do we secure our VPC? So our VPC, as I said, is the housing, or is that housing which we have within the AWS cloud. There are several components which are within excuse me, which are within the VPC element, which provides element of security. As I mentioned, you partition this, there's partitioning which we used, and those partitioning, you can look at those as rooms. So when when you more or less secure your rooms, you put a lock on those. So you can put in your partitions itself, your subnets, you can add a layer of security there, which provides it. Um, And so that's the first thing. And how do you typically protect that? You have more or less networking elements such as routing tables. You have network access control list. Um, you would have your compute resources in your private and public domains. You can use security groups. You can you can use security groups in order to provide you the level of access as I mentioned. Now, no VPC in itself is totally isolated. So you have a VPC that is connected to the internet. You see, but similar to when you have a house, you protect your house from, from the outside world by having a fence that is around your house. Similar kind of thing with a fence, but when you have a fence, you can have a means by which people can securely get in and out of the house by a gate. And that's what is called an internet gateway. So you start to see how this is analogous to how, things that you see in everyday life. So in a way, it becomes very much intuitive, very much common sense. Mm. So you have a gateway there. So a gateway is just a, a, a secure location where things can get in and out of your VPC itself, right? And then not only that, when you you go beyond your internet gateway, which is the last gate which you go before you can connect your VPC to the internet, you can come into another area which is called a NAT gateway, which is network address translation. So what is that? You'd find when we deal with the networking element, network address translation is the means by which you can protect the identity of the resources that you have in your private subnet. So if you want to connect to assets which within your private subnet, if you don't want to reveal it to the outside world, you don't want to announce what you have to the outside world, you can use what is called a network address translation gateway. And there are mechanisms by which you can do so. So within this diagram, you see here there are a number of components which you can use from the internet gateway router. Uh, and from this internet gateway router, you can put what is called a firewall, which is another security layer, security device, which more or less monitors who can come in and out of this VPC. Mm. And with that, when you go through that, then you got a NAT gateway, you got the partitions, as we mentioned, which are public and private subnets, which are in place. You got the routing tables, you got the network access control list, and the security groups, which we're going to see a bit later on. Yeah. So this visualization here gives you a great idea of what you're actually faced with in terms of providing security to your VPC. So the first element that I'd like to look at is security groups, right? When we look at security groups right now, we're going to look at it from the point of view of our compute resources. So what are compute resources? These are the resources upon which, these are the servers, these are the machines which actually run where um, your applications, your database, actually runs. It's where your web front end is actually running from. You see, so you have your software which is installed on your instances, which are more or less uh, uh, um, your your uh, uh, your computers or your servers. So a security group is the first line of control that you ever have, right? A security group. So a security group is, look at it this way, is that it's like putting a lock, putting something within a box. So you are taking your instance, putting it within a box, and then you're putting a lock on it. Yes. So it controls, but the thing about it is that it allows certain amount of traffic to go in and out. So it doesn't totally isolate your instance totally. So there's an element whereby it allows traffic to go in and out. But the most important thing is that you control what traffic actually goes in and out. Mm. So you can assign up to 5 security groups per instance. And the most important thing is that they operate at the instance level. So when you're looking at your component, you've actually set up the instance that you want, right? This is where a security group comes in. So it protects that instance. Yeah. So every single VPC there, within your VPC, you have several instances. Each of these instances can have their own individual security group. Mm. Or you can decide and create, let's say, one security group to protect all your instances, or you can use multiple security groups as an how you like that to happen. Mm. But I think the main thing to talk about there is that this is like a virtual firewall. And a firewall is just a concept which you'll get to understand. So a firewall is more is a device which controls what comes in and out of uh, 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 comes in and out of the entity that you're trying to protect. It doesn't provide total protection, but it more or less monitors or look at a firewall like, let's say, like a security guard. Mm. A security guard will monitor who is a good person and who is a bad person that's coming in and out of a house. If the security guard does not recognize you, then the security guard does not allow you enter the house. Mm. If the security guard does allow you, then you are free to enter the house. It's the same kind of concept that we're talking about. So again, components of a security group, as you say, in the real world, what does this actually look like? You see, so you see your VPC resources, you see your subnets that I mentioned. So those are your partitions. So within your partitions, you have your instances. Yes, these are the orange bits down here. So within these instances as well, in order to protect access to these instances, you have a security group. So you have a security guard which is there, which protects you getting access to this. This is your treasure, right? When so that provides you your your security from in the partition layer, yeah, within the subnet. And once you break out of that security group, you're going further, then you're using what is called a network access control list, which is then looking at the providing an extra level of security, which looks at the what is called the IP layer or the network address layer. So that's what a NACL is. And the beautiful thing about a NACL is that it more or less protects, controls what traffic goes in and out. Um,
Akwo, I think we miss you. You are on mute. Can anyone hear
yes, yes,
Akwo?
yeah.
Okay.
What do we have? Is it
Okay.
time? Is time up?
No, no, no. We did not. We lost your sound for a moment. It's okay now. Continue.
Okay, okay. Sorry about that. So this diagram shows you you see the various components right now, and you see how this security group now, how it fits within the whole context of what I mentioned earlier. So you see a security group here, you see a network access control list, you've got a routing table here, you've got a router here, a router here, which is more or less a controller. So a router always looks about controlling what goes in and out of here, or it's more or less like a traffic conductor. It decides what direction traffic has to go within the VPC. And I mentioned the internet gateway, which is also there. What is not within this diagram is what is called the firewall, the WAF and the shield, which are not there. But the focus here is on the security group, as I mentioned, which is the lowest component that we can start with. The next lowest component we're going to look at is the NACL, the network address access list. So as I mentioned, this operates now as what is known as a network layer. So when we're talking about the network layer, we're all talking about traffic, where traffic goes to, how you control where traffic goes to, what traffic has access to your security group. Mm. So that is why we're saying that it works at the subnet layer. So it's looking at traffic. So it's controlling traffic in and out of one or more subnets, right? So when you implement a NACL, as they call it, a network access control list, you set up rules. So these rules now determine what traffic has access to your partitions, right? Those are to your subnets. That's the purpose of having a NACL. So it controls what traffic. So if traffic has to come from the internet, you can decide what rules, what is the identity of the person or of the people that can access that partition that you have within the AWS cloud. Mm. So that's why NACLs are so important for you, you see. And what are the components of a NACL, which is the Nexus Access Control List? Basically, there's a real a tool set, but ultimately what it does is that you can control what goes inbound, what comes into a partition, and you can also control what goes outside of a partition. Yeah. You can set up the two things to be the same, or you can set them up to do different things. So you can either allow certain traffic to come in, or allow certain traffic to go in or out, or you can deny specific traffic from going in and out. So you'll find that from a NACL perspective, you're either allowing certain traffic or you're denying certain traffic in place. So those are the components that you need to take in. And what is very important is that it applies, it can control what comes in and what goes out. Mm. And you always apply that to the subnet, as I mentioned there, the partition. That's very important. So you can, as you can see here, the illustration here is that there's somebody who has a computer which is foreign to the VPC that wants to access these instances. Now that person there is not authorized, so that person is denied by virtue of this network access control list. Because what happens here is that there is a rule which is inbound that says that any traffic coming inbound which comes from this source here is not authorized, so you are not allowed access. But meanwhile, this other operator here is on an approved list. So what we have said is, what can be said there is that traffic which is identified coming from this particular identifier here is then going to be permitted, is going to be allowed inbound, is going to be allowed in to access this. So what you can see here with this illustration is that you can see how two different entities on the internet can be treated differently. You can control who has access to your environment in the cloud, and that's going to be the fundamental element of what you do. And you can achieve that using a network access control list. Okay, so what are the main comparisons between a security group and a network access control list? This is going to be an important element for you, especially when it comes to the exam as well, and also to when we start setting this up. I would say primarily that these two things are complementary. You have to understand at what particular layer that they're operating. Yes. So the first thing is that they serve different purposes. They are both focused on security, but they look at different aspects of security, you know. So if you are talking about having a padlock offers a different level of security to, let's say, a combi to let's say a combination safe. There are two different things. Um, you can also say that a padlock is different from uh, something which is a padlock is different from something which more or less hides, which is used to hide your thing. So you can disguise, for example, where you have hidden something. Yeah. So you can make it look less obvious that that thing is important. So you disguise it. So um, when we're looking at these two components, understand what they serve. So the security group operates at the instance level. So this is your actual servers itself, your compute component. That's where it operates at. So when you implement a security group, it protects your servers. The network access control list, this protects your subnet. This protects the partition. Yeah. The other thing is that how does it do this? Security groups only provides allow rules. So security groups are there to just allow certain traffic to come in. So there are no deny rules with security groups. But with network access control lists, there are allow rules and deny rules that apply. So that's a fundamental difference. Now, there's this element which is called the elements of what is called stateless and stateful. I'm not going to go too much into those elements there, but the elements, as in time that you start to go through, you would understand what these mean. But the long and short of it is that a security group provides you with stateful access. So therefore, what that means is that if it allows certain traffic to go out of a security group, that means on the converse is that that same type of traffic um, that is allowed to go out is the same type of traffic that would be permitted to come in. So put it this way, if somebody is wearing a red shirt, is leaving a house that wears a red shirt, and if somebody is coming back into the house that wears a red shirt, that person will be allowed in. So somebody coming in with a green shirt or with a yellow shirt does not have a red shirt, for example, will not be allowed in. So with stateful inspection or with stateful traffic, um, somebody that is being permitted to go out, uh, as long as that person meets the same rules that was used to go out, that person is allowed to come back in. So you don't need to state it. But on the other hand, when you look at a network access control list, right, you can set up two independent rules. Um, so you can determine who is allowed to go out of your house, but you can also determine who is allowed to come in. So the same person who is allowed to go out of your house, you can say that, okay, once you go out, you're not allowed to come in. That is stateless. So stateless just means that it doesn't matter what what the connection between what goes in and what goes out. There's no connection. You have to explicitly state it. So it's stateless. Mm. You need to explicitly say what goes in and what goes out. Okay. The other two elements you read on yourself, but I think I've just covered the main three elements for you to know how they're being delivered. So I think the first three anyway are the ones that you should always remember at in a deep way. The other two elements as well, which you can read on your own. I'm not saying that they're not important anyway, but I'm just saying that for now, knowing these topics, the first three elements, understanding the difference between the two is important. So with that being said, we go now to our last section now, which is called VPC Flow Logs. Um, so what are flow logs? Um, Logging is all about understanding what is happening. So logging is all about information. So when anything is happening within your VPC, the important thing to note is that that generates a lot of information. So logs is kind of like information about what is really going on. So VPC flow logs is all the happenings, ins and outs, the happenings of what is happening within your VPC. So that's what you have within your flow log. Is this important? It is. It's just like, let's say, like a an inventory. Like I said, we come down to the analogy of the house. You know, who comes in and out of your house? If you have a register there, anybody that comes into your house, you register. You know, in a lot of buildings that you come into, sometimes you have to give your identity card, your passport, your national ID. Somebody has to note it. A security guard would note it, take your name, your car or your driver's license ID or national identity ID, it's the same thing as well. So anything that is happening, somebody is logging, what's your name? Who are you here to see? Do you have an appointment? The same analogies, it happens within the VPC. So anything that is happening within the VPC, it is logged. If you went round to the fifth floor, or you went to this particular partition, you went to access this particular server or this particular application, that is logged in terms of the VPC. Why is this important? Well, this is important because it helps us to more or less monitor what is already going on within our VPC. And it's also important because we can also use that as a security tool. We can use it to actually detect what is normal behavior or actually happening within our VPC and what may be abnormal behavior. That's why it's important. Yeah. So if you see something happening whereby you say that, okay, only certain uh, uh, um, entities from outside of your VPC are allowed to access a particular application, then you see a foreign entity come in which you don't know anything about, that puts up a red flag. You can say, oh, this is not supposed to be happening, right? And then you actually, what you would do is that these VPC flow logs are kept in a repository. So they can actually be kept in Amazon S3, which is a good storage entity, object storage, or they can be sent to CloudWatch logs. So CloudWatch is, as I mentioned, is a means by which you can actually monitor things. So it has a number of alarms, and then you can connect that CloudWatch logs to other elements such as Lambda, which is function as a service, for example, or event bridge, or you can also tie it into other services like SNS or notification service or SQS. So these are things that you'll get to know later on. But I think the main thing is that the flow log data is managed by CloudWatch and with Amazon S3. So that in itself concludes the entities about network security. Um, so that being said, we've come to the end of our presentation for today. I've spoken a lot, and just to summarize everything of where we are, we have looked fundamentally at four different components. We have reviewed what is security in respect of when we're talking about cloud services. What does that really mean to us? So that is something that we need to be conscious of, because the environment is different. As I mentioned, when you look at your house, that gives you an idea of what type of security measures you can take. The same way when we look at the IT space, um, there are a lot of cybersecurity threats out there. If we understand what the threats are, then we can take steps to start protecting ourselves. So that's why we have all these security services which are in place. We also mentioned as well um, how security is viewed in the cloud. We talked about the AWS well-architected model, why that's important in helping us develop and build systems in the cloud that are secure. We also looked at what is known as the shared responsibility model, which is uh, the responsibilities or the roles which the various parties when it comes to cloud services have to do. So AWS has its own role that it has to play in delivering security. And then we, the clients, the customers, have our own role that we need to have when we're delivering security to make sure our environment is secure. So it is a partnership in delivering that security. But the important thing is that everybody needs to fulfill that part in order for your system to be secure. We then had a review about the seven different elements by which we can take, or best practices, which we can take to actually protect our assets in the cloud. We looked at it, principles of less privilege. We looked at elements such as logging. We looked about elements such as automation of security services. We also looked at elements such as protecting our data when it's at rest or in motion as examples. Those are just four which I've covered. And I also, during that time, we highlighted some cloud native. So when I say cloud native, these are AWS services which are in the cloud, which can be used to provide those security functions that we needed, which we reviewed. We're going to review some of those services in more detail in part 2 next week, which we'll do. And finally, what we also did, or what we've also reviewed, is that we looked at network security. You got to understand the VPC, the basic networking component of the AWS cloud. You've understood its infrastructure. You've also understood as well how this is set up, it is built, and how to protect the various layers which are within the VPC. So we looked specifically at security groups, number one, providing the first layer of security. And then we also looked at network access control list. And then we've also identified the difference between the two, what they actually serve. So that is a review of what we have covered today. I would say that for the time being, there are no actual questions that I'm going to give right now. I think we'll leave that for the session part 2. But in the meantime, if any of you have any questions that we can take for the next 6 minutes, then I'll be happy to review that with you. So Banjika, over to you. If there are any questions that people have, then please please make a mention. So this is the agenda as we've mentioned. You can tell me how you found the session. If there's anything that you would like me to explain again, I'll be more than happy to do so. Okay. Right.
So any particular questions, team? If there's something, remember there's still a session next week. So unfortunately, we'll have just 5 minutes. But is there any particular question you may have? Okay.
Somebody was talking about security groups and knuckles, but don't understand the difference between supports allows rules for security groups and supports allow rules. Was that Divine? Okay, Divine was asking something there. Divine, did you have any clarity about that, or are you still asking that question? If you can come off mute, Divine Mofu.
He asked that 2 minutes ago. Yeah.
Okay.
I think his connection is poor. I think he asked that 2 minutes ago. Akwo, maybe you just conclude explaining that. So,
okay, yes. So again, you know, security groups, as we say, are applied at the instance layer. So when we're talking about an instance right now, we're talking about the base component from which we are delivering, we're accessing or delivering our cloud services. As we mentioned here, the thing about security groups is that they only have allow permissions, so they are stateful. So the traffic which is allowed, if you allow certain traffic in, then that same traffic that you allowed, type of traffic that you allowed in, is allowed out. You don't need to state it again. You don't need to add a rule for traffic to go out because it's the same traffic that goes in. Conversely, if you say that you permit certain traffic to go out of your instance group, then that same traffic will be the allowed in. So that is that's the fundamental point. Now, when you're looking now at the network's access control list, this is another security mechanism which lies outside of the instance. So it applies now what you call now to the network layer, which is to the subnet. So as I mentioned, the subnet is all about the partition. So the partition really is, you set that up using what is called IP addresses. Yes, so it's a portion which you can control what goes in and out, what can access those IP addresses. Because I mentioned IP addresses are identifiers. So they're used to identify your assets and your services, your instances within your subnet, right? So when you use a NACL, you are controlling what has access to your instances. Uh, so you have to you can specify what comes inbound and what goes out. The two are not related. That's why it is stateless. So you have to specify what is allowed, to actually come in or out. So you can either allow traffic in or deny traffic in. In conversely, you can allow certain traffic to go out, and you can also deny certain traffic to go out. So you see that the allow and deny permissions are available for a NACL, but for a security group, you only have the allow permission, which is in place. So you see that these two things now function at different levels. Okay. Yeah. So always remember that the security group functions at the instance layer and the NACL functions at the subnet layer.
Yeah. Okay. Thanks for that, Akwo. Just I see Divine says he's understood that. Just to highlight, some of these things may look a bit abstract, but when we do the lab sessions, it will become much more clearer. And especially, we'll still cover the network, and we'll do a pre-intro to that. So when the network layer, the network topic will be covered, most of the things also will become, in case you are still having difficulties. So I just want to encourage everyone to, to look forward to that by the time we come, and especially during the lab sessions, you'll be much more comfortable. So let me go ahead and just stop the recording.